Hello, everyone. Last week, I put a video which was basically a question for both sides, asking if they can explain an observation using the model they support, and if it makes any sense under the rival model. The observation I showed was the angular speed of the sun being 13.74 degrees per hour, and it was a part of David Marsh's twin observation, filming the sun from UK and USA on the 26th of June, I think 2018, around the solar noon time for each location. There was no answer from the flat earth side and some skepticism from the globers, since the number was 13.74 instead of 15, and only one response that was very close to the correct answer for the heliocentric model. So here's my answer. The Earth spins 15 degrees per hour under the heliocentric model. So the sun and stars and every celestial body should appear as if it spins 15 degrees per hour relative to us, right? No, not exactly. A star near the North Pole would make one round in 24 hours around the North Celestial Pole, but the angular speed of that star would be way less than 15 degrees per hour. Imagine yourself in the center of a glass Earth, watching an object traveling on the equator, making one round every day. That's one longitude line, or 111.2 kilometer on the equator every 4 minutes. And if you watch another object traveling on the Tropic of Cancer, making one round every day also, that object will be covering one longitude line, or in this case, 102.1 kilometer on the Tropic of Cancer every 4 minutes. Now you can see that the angular speed of an object totally inherits the object's rotation if it was on the same plane, aka the equatorial plane. And it reduces with a specific amount the higher that object goes towards the rotational axis. So, like again, another example, Polaris rotate in the sky one revolution every day in a tiny circle, and its angular speed is, well, good luck measuring that if your time allowance is few minutes or even up to an hour. It's something negligible. So enough talking, let's get to numbers. The angular speed of any celestial body would be 15 degrees multiplied by cosine, the declination angle of that body. So on the 26th of June, the sun's declination angle exactly 23.348 degrees. So 15 multiply 0.918 equals 13.77. That's 0.2% difference from the results that came from an amateur astronomer, which is considered to be perfect match, bearing in mind the tools and method being used to get to that result. Now, the second part of the question regarding the flat Earth. That result doesn't make any sense, since there's loads of variables that would change the angular speed of the sun. The sun speed as it speeds up 70% on winter comparing to summer, while it speeds up only about 3% for the heliocentric model for the same periods, which can be ignored in the accuracy level of our amateur tools. Secondly, the time of the year, which defines which latitude line the sun is above, and this is the only significant factor for the heliocentric model as well. The third factor is the time of day. Then Number 4 is longitude. Number 5 is the latitude of the observer. So all of these variables governs the observed angular speed of the sun. So how can the same observation made from different longitude, different latitude, and different solar time for each yet still get the same result? Not to mention that when I calculated the presumed angular speed for the sun in those two locations, it came around 18 degrees per hour for Dave and 20 degrees per hour for Jana. I think that concludes the answer that I promised. Thank you for watching.